2014, a giant crater was discovered in the Yamal Peninsula in northern Russia. This wasn't just a little hole in the ground. It was 160 feet deep. But how it got there was a complete and utter mystery. It turns out that the answer would have global implications. From GBH in Boston, this is Nova Remix. I'm Caitlin Sachs. Around the world, huge holes can suddenly open up in the ground, usually because water or erosion has weakened the ground underneath. They're called sinkholes, and they can be scarily big. Some swallow cars or city streets. So when a massive hole was discovered in the Yamal Peninsula, geologists like Dr. Vasily Bagoyevlensky rushed to investigate.
When we just came to this crater, of course, we didn't know for sure what was there. We never saw something like that, never.
The hole in the Yamal seemed different. Most sinkholes collapse inward, leaving a flat rim. But this one had a raised rim. That suggested the hole didn't collapse inward. Instead, it looks like it may have exploded. Just try to picture that.
Pieces of rocks and ice are flying, sometimes in quite a long distance, from 200 meters to 500 meters, and in one case it was distance to 900 meters.
Asteroids can cause a lot of scattered debris, but there was no additional evidence of any impact. That left only one reasonable explanation: a subterranean blast. First, they wondered if it might be a volcano, but with no lava or volcanic rock on site, that seemed unlikely. But investigators did find something strange at the bottom of the hole: unusually high levels of a flammable gas called methane. Methane is the main ingredient in natural gas. You know, the stuff powering gas stoves and many heating systems. Could methane be the culprit? And if it were, where did it come from? Then, at least 7 more giant craters were discovered in the area. What was going on? A clue came from across the Arctic Circle, about 2,500 miles away in Alaska. In 2017, a pilot reported that a lake in the wilds of northwestern Alaska was behaving oddly. The water looked like it was boiling.
It's just mysterious. It looks like a jacuzzi. And so you get up to it and you can hear these boom, boom.
That's field technician Phil Honka, who investigated this lake, known as Easy Lake, with a team of scientists. One of them had a personal connection to the lake.
My name is Janelle Sharp. My Inupiaq name is Anosuk. My mom is originally from Kotzebue. My family is from this region, and so this project is really special to me because it's kind of like me coming back to my roots. If you fly low enough, even from the air, you can see the bubbling. We took gas samples, and then those were sent to the lab for analysis, and they found that it is a super high amount of methane.
Methane leaks, known as seeps, have been found in the Arctic before, but they're usually much smaller. Nothing like this, or like what would be required to create an explosion. The team's measurements showed that Easy Lake was belching out over 10 tons of methane every day. That's roughly the amount 100 cows produce in a full year. Just like the craters in the Yamal Peninsula, Easy Lake had a strange amount of methane. So the scientists wondered if maybe the methane's source could explain the craters. From the lakeshore, it was difficult to see where the methane was coming from. So geophysicist Dr. Taylor Sullivan put on his scuba gear and headed into the frigid, bubbly water.
I was kicking really hard to stay down along the bottom, and I was moving my hands along it. And it went from this mushy lake bottom that was flat, 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 and then it just dropped out.
In the murky waters, most of the lake bed was just a few feet deep. But Sullivan found a weird anomaly when he moved along the lake floor toward the bubbles.
Yeah. It's like you're on the bottom, bottom's gone.
The bubbling, it sounded like seeping gas, as if it was even from a propane tank.
Sullivan found the methane bubbles were streaming up from a hole in the lake bed 50 feet deep. It was a sign that methane was stirring beneath the lake bed. And this was especially interesting because Easy Lake and the Yamal Peninsula are both located on the same type of frozen terrain, permafrost. Could that be the source of the methane? Permafrost is any ground whose temperature stays at or below 32 degrees Fahrenheit for 2 or more consecutive years. But it can stay frozen for millennia. Most permafrost is found in high northern latitudes, including Russia, Canada, and most of Alaska. It covers an area almost as large as the US and Canada combined. And permafrost is full of some pretty cool stuff. Near Fox, Alaska, cryosphere scientist Dr. Tom Douglas took us through a tunnel in the frozen ground for a tour of what you can find in the permafrost, and the next clue in our methane mystery.
That's a horn. That's from the longhorn steppe bison, and they are extinct now, but back 18 to 40,000 years ago, there were steppe bison here. Pretty exciting. This is a mammoth bone right here. You can just see kind of the piece of it sticking out right there. It's pretty big.
Here, down in this permafrost tunnel, you might imagine a crystalline cave sparkling with ice. But that's not what it's like at all. It looks more like walking into a mine. Think of a tunnel through frozen dirt with some occasional big wedges of solid ice. But the dirt is the interesting part. It's filled with the remains of ancient animals and plants.
So these are sedges, kind of like grass, and you can see that they're green. They still have their chlorophyll in them. They're also upside down. This block fell into a water feature that then froze, probably 20 or so thousand years ago.
That ancient organic matter, like all life on our planet, contains carbon. When living things die, they decompose, releasing some of that carbon back into the atmosphere as carbon dioxide and methane. But in the freezing Arctic, decomposition happens slowly. That's why there were ancient sedges in the Fox Tunnel. They froze and had not decomposed, even over thousands of years. The carbon was trapped in the permafrost.
In the late 90s into the 2000s, people start to look at the stocks of carbon in permafrost, and it's a lot. It's about 1,400 billion metric tons. It's almost twice as much carbon as is currently in Earth's atmosphere. When we walked in, we noted that smell, right? You're smelling ancient bacteria and carbon being oxidized. It's almost like I've heard anything from like a French cheese to barnyard, but it's kind of that organic, almost a late fall, wet leaf kind of organic smell. You are smelling permafrost carbon being oxidized. And so the big question is that carbon that we smell that's all over this tunnel walls, what's its ultimate fate?
In other words, what happens to the methane and carbon dioxide that's seeping out of the permafrost's decomposing organic matter? It could be rising to the surface in the form of bubbles, but the team at Easy Lake discovered another complication. Based on the methane bubble's distinctive chemical signature, they didn't come from just the permafrost. They also came from below it. Nova and Nova Remix are supported by Carlisle Companies, a manufacturer of innovative building envelope systems. With buildings responsible for over a third of total energy use and energy demand on the rise, Carlisle's mission is to meet the challenge head-on. Carlisle's advanced, energy-efficient, and labor-saving solutions can help reduce strain on the grid. Operating nearly 100 manufacturing facilities across North America, Carlisle is dedicated to helping the transition to a smarter, more sustainable future. Learn more at carlisle.com. Nova and Nova Remix are sponsored by Viking Cruises. Ocean voyages, expeditions, river journeys, Viking is dedicated to bringing travelers closer to the destination, offering a small ship experience and a shore excursion in every port. Learn more at viking.com. Permafrost is not the only place methane is stored in the ground. In fact, the majority of so-called fossil methane originates from decomposed organic material that's millions of years old and miles beneath the surface, much older and deeper than the permafrost. It's usually regarded as stable because it's trapped under permafrost and solid earth. But if it's stable and trapped, then how could it bubble up through Easy Lake? Sullivan from the Easy Lake team had a thought.
Looking up at the peaks around here and studying the local geology, we know that this is a highly fractured and faulted region.
Fault lines and geologic activity could explain how methane trapped deep within the Earth's crust could rise to the surface. But that gas would still have to pass through what should be a rock-solid permafrost layer. The team knew that there was a 50-foot hole at the bottom of the lake, but that didn't mean fossil methane had a way to leak through, because permafrost layers can be 500 feet thick or more. So, to see deeper, geophysicist Nick Hassan joined the team.
I'm essentially scanning the permafrost using a geophysical method called very low frequency. When it moves through the ground, if there's permafrost or ice, these waves are coming up against a lot of resistance. But if there's no permafrost or ice, it quickly moves through. And so we can scan the Earth similar to how a doctor scans you with an MRI.
Very low frequency, or VLF waves, are sent out globally by the Navy to communicate with submarines. But as those waves pass through the Earth below, Hassan's equipment could pick them up. By measuring the speed the waves travel, Hassan could tell whether the ground deep beneath him was frozen or not.
Well, we're over the largest seep, and there's some sort of large anomaly happening right here where I'm located. And the VLF is picking it up. It's very exciting. The signals are just outstanding.
There should be permafrost covering this entire area, but for some reason here is a thaw chimney going from somewhere below 150 meters to the surface, where we see the rising bubbles.
With the VLF equipment, Hassan could see that the ground beneath the lake was less frozen than it should have been. The permafrost had thawed enough to allow methane from deep within the Earth's crust to bubble to the surface. This means that thawing permafrost not only releases methane from within itself, but also creates pathways for ancient methane to escape from the Earth's crust below. Easy Lake's methane source was confirmed. And this also partially explains the methane from the Yamal Peninsula. It too is fossil methane, finding an escape route through the thawing permafrost. It doesn't explain why the methane there was exploding. We'll get to that. But first, scientists like ecologist Dr. Katie Walter-Anthony were alarmed that methane was reaching the surface this way at all.
If permafrost thaws, then that's a scary wild card in the climate change story, because we think there's a huge amount of methane and natural gas trapped inside permafrost and under permafrost. So if permafrost becomes like Swiss cheese with lots of holes in it, then you can have chimneys where that gas is erupting out. And that is not included in climate models.
The climate models that Walter-Anthony is referring to are trying to calculate how greenhouse gases might warm the planet. Arctic ecologist Dr. Sue Natali explains more.
Greenhouse gases are a concern because they trap heat. They're helpful to us because they make this a habitable planet, but because there's too much in the atmosphere, they're now making this an uninhabitable planet or a less habitable planet.
You've probably heard about how carbon dioxide is a greenhouse gas that insulates our planet. As we add more to the atmosphere, from the burning of fossil fuels, for example, we're seeing the world get warmer. But Natali explains what makes methane a real wild card in this situation.
Methane is really important because it's much more potent in terms of its ability to trap heat. So it's about 30 times more powerful than carbon dioxide.
Luckily, while carbon dioxide lasts centuries or longer in our atmosphere, methane only lasts around 12 years. But scientists estimate there are around 1.3 trillion tons of methane stored beneath the Arctic. That's over 200 times as much methane as there is in Earth's atmosphere today. And while the leak at Easy Lake is unusually large, it isn't alone. More than 70 smaller seeps have been found in Alaska alone. Some scientists expect that these methane leaks are part of a cycle that results in more warming and therefore more methane leaks. For instance, when the permafrost thaws, the ground sinks and in some cases fills with water.
And once a lake is formed, you can't stop it because that water has heat and it causes the ground to thaw so fast. As the methane escapes, it causes more permafrost to thaw and more methane to be generated, which is more warming, and you get what's called a positive feedback cycle.
Positive feedback cycle is one where the cause and effect inherently benefit one another. More warming means more permafrost thaws. The more permafrost that thaws, the more methane that enters our atmosphere. The more methane that enters our atmosphere, the warmer it gets. And so the cycle continues. Geophysicist Dr. Vladimir Romanovsky has seen this himself studying permafrost in Utqiagvik, Alaska.
Before it was more or less flat area, but then ice melts and surface subsides. It took tens of thousands of years to put this ice into the ground. Now it's melting. To put all this ice into the ground back, you will need several tens of thousands of years. So that's, for humans, definitely irreversible process. It is tipping point.
Nothing seems to suggest that the Arctic could be reaching a tipping point more than the exploding sinkholes on the Yamal Peninsula. But why is that the only Arctic environment that is literally exploding? The final piece of the puzzle hides inside the Yamal Peninsula's permafrost layer. Located sporadically amongst the frozen Earth are small 3-foot pockets of salty water. Now, salty water freezes at a lower temperature than fresh water. So here, these pockets of salty water are below freezing temperatures, just like the frozen permafrost above, but it remains liquid because it is so salty. And beneath these saltwater pockets are pockets of fossil methane, or in this case, methane hydrate. That's still methane, just crystallized by freezing temperatures and pressure. So, when the permafrost layer melts, the fuse is lit. Fresh water from the permafrost layer is readily absorbed by the saltwater. As more and more meltwater enters the saltwater pocket, there isn't enough space. Pressure builds, fractures form in the earth above, and boom! During the sudden pressure release, the crystalline methane is destabilized and turns into gas, further fueling a violent explosion. Mystery solved. These explosions aren't expected to be a common occurrence, but it's also clear that this activity indicates that the Arctic is changing.
These craters are a really important and concerning indicator that things are changing and the Arctic is melting and the Arctic is thawing. And the future of the Arctic is a very different place than it was several decades ago.
This has been an episode of Nova Remix. Subscribe for more episodes and drop us a comment with your thoughts or questions wherever you get your podcasts. And if you want to see these craters for yourself, check out the documentary Arctic Sinkholes on Nova's website, YouTube channel, and the PBS app. Nova Remix is a series from GBH and Nova, and it's distributed by PRX. Executive producers are Julia Court and Chris Schmidt, and Senior Director of Digital Media is Nadia Petchek-Rawls. Devin Maverick Robbins is Managing Producer of Podcasts for GBH. This episode was produced by Chris Neighbors with sound design by David Porter. I'm Caitlin Sachs.